Hi, welcome to the program with Sam, and this is C, lesson 3. So last time we examined the variable types available to us, and we discussed how there were many possibilities for things we could do with the introduction of arrays. This time we're going to be putting some of these ideas and concept into action, and we're going to be writing some actual functions to and we're going to demonstrate recursion as well. So declaring a function in C is done by having, well, obviously we can see it with the main, but let's say we wanted to do something else. Let's say we wanted to do int, and we wanted to add, and it takes two arguments, int a and int b. And that's how we'd like declare the function, and then we'd sort of have space to put a body in that function. It's very similar to Java that we've seen before. You just have sort of like your modifiers. So if we wanted to say like static, for instance, that's something that we could do. But so yeah, you have your modifier, then you have your return value, the name, and then you have your arguments in the parentheses. So with the function declared and with it taking some arguments, you can then write the body. So in this instance, what we're just going to do is we're just going to return a plus b. And what that'll do is it'll take two numbers, a and b, add them together, and return the result. Now, what happens if we do it like this? Because obviously in Java, it doesn't matter where you declare your functions. But if we put the function after main, and we call it with 2 and 5, say, if we do that, it's all syntactically correct. There's no syntax errors. But if we go to try and run it, it's come up with build errors. Now, this is because main is defined here, but add is defined after it in the file. So it doesn't know that add exists at the point when it's trying to compile main. You can get around that by writing int add int a int b and just declaring the function at the top and then defining it later on. And there you go, it compiles perfectly. And that's sort of the difference, and that's sort of leading on to something that we're going to touch on later, is how header files work, where you declare it in the header file and define it in a separate C file. But we'll get to that later. So that's one way of doing it. You can declare your function and then define it later on, or you can just do it all before the main function, and we give that a run. Number is 7, which is what you'd expect when you pass it 2 and 5. So now when we're calling that function, we're passing it the values, obviously, and it's adding them together. Equally, we could make another one called multiply. So int multiply, and it could take int a, and it could take int b, and then in here we'll just return a star b. Like so. And then we could change this to multiply, and now the number should be 10. Boom, number 10. So that's sort of how functions work and how you can then throw arguments to them and operate on those arguments and return a result. So the way recursion works is that the function is going to essentially call itself, but with updated parameters. So if you have a function and it gets called with some parameters and it's operating on those parameters, at some point during the method of that function, it will call itself, but with updated parameters. That function will then call itself again with updated parameters, and again, until a solution is converged upon during the algorithm. One of the examples, like one of the most common examples, I guess, of recursion would be, say, a Fibonacci sequence. So let's take a look at how we would do that in C. So when it comes to doing our Fibonacci sequence, we're going to want an int, and we're going to call it fib, and it will take an int I. And so this is our function. It's the Fibonacci function, and it's just going to take an integer I. And we're going to say if I is then equal to 0, it's going to do something. Otherwise, if I is equal to 1, it'll do something else. And then if all else fails, it's going to return something entirely different. And it will return fib, and it will do I minus 1. And it will plus fib I minus 2. So it's the previous two numbers added together that it's returning. So if then we have I is equal to 0, we just want to return 0. Or if I is equal to 1, we just want to return 1. And that's just going to account for the first couple of digits. And I, of course, need to remember to put my semicolon in. There we go. And that's pretty simple. Like, it's just going to keep calling itself, and it's going to keep calling itself. What we essentially want to do now is we want to now have a loop, and we'll come to loop this next time, but I mean, you're probably going to recognize the format of these loops because we've done it before in Java and they share basically the same syntax. So let's let's do 25 and I++, and what we'll do is we will printf, except the compiler, just the IDE doesn't auto-correct things for me, printf %d/n, yeah, that'll probably do actually, fib I. So what this is going to do is it's going to go for 25 iterations, and it's just going to call the Fibonacci function on it. Oh, for God's sake. Well, I know what I missed. It's the return statement. So now if we run it, there we go. That's the Fibonacci series. And that's an example of recursion in C. Another example would be Factorial. And Factorial is just sort of multiplying the number by itself. So if we then say int Factorial, and we have, it's going to take int I, and what we'll do is if I is less than or equal to 1, we don't need to do anything, we can just return 1. Otherwise, we return I times Factorial minus 1. But that should be the argument, I think, yeah. I minus 1, boom. And what we can then do is printf /n 9 factorial equals %d, and we can give it factorial 9. And so that should then just calculate 9 factorial. And if we run that, boom, it tells us exactly what it is and it's calculated it. And that's sort of one of the benefits of recursion, is that you don't have to write as much code. And it's quite easy to write that code. And you don't necessarily have to write the loop, because in this instance, we don't have to write a loop that iterates from I to I minus 1, doing it like that. We can just have it call itself and then return the value. Now, the benefits are obviously is that it's very neat and it doesn't require as much code reuse and XYZ. But the downside is that it's more computationally expensive in terms of sort of memory allocation, for instance. You need a lot more memory to run recursive functions than you do to run normal ones. But nowadays, we have so much memory readily available and so cheap, it doesn't actually make that much of a difference. So recursion is quite sought after in terms of algorithm making, because it is just a nice and pretty easy to understand way of coding some algorithms, like the Fibonacci or the Factorial. And that's about going to cover it for this time. Next time, we're going to be looking at creating header files and creating the corresponding body file. And then we'll also be having a look at then sort of incorporating those files into your own project, with the goal being that you could then go off and build yourself a C library. If you'd like to follow me at ProgramSamBlog, or follow the blog directly at programwithsam.code.blog, that would be much appreciated. And I will see you in the next one.